Hey guys, so in today's video what we're going to be doing is pretty much what we're going to be doing every video for the next couple of months. So what I have here in front of us is we've pretty much got Anki, which is a flashcard set for those that don't know, and the ultimate reason for using flashcards, particularly with Anki, which is a free software you can download, with regards to space repetition. So the idea is if you learn something on day one, you'll then study it on day two, and so long as you feel really confident in on day two, you can then study on day four, and then eight, and then really whatever the day might be after that. But the point is so long as you learn something, you'll be able to retain it. So I might leave a link in the description to download Anki. Just go ahead and search it on DuckDuckGo, and then from there, yeah, you should be good to go. But what we're going to be working with today is Pandas, Python, and we're going to review some of the old flashcards that I've used, and then from there we're going to go ahead and transition and use what we've learned in the flashcards on an actual data set. So this entire thing should take around 40 minutes. But yeah, we're just going to pretty much just practice recalling what we learned, so that way we're able to retain the information and the knowledge. So I have 35 cards I need to review. I'm not going to actually review all of them. I have 4 that I'm learning, and let's just jump into it. So let's study. So as you'll know, and as you'll see, some of these cards will have the answer side show first, and then you'll need to figure out what the question is. And others will have the question first, and you'll need to have the answer. Just know when you do create your flashcards, it'll start with the question first and then flip. But because I'm reviewing this card, it's shown the answer already. Or it's not, but it will eventually. So this question's asking in Pandas, or it should be kind of just obvious. In Pandas, how would you rename EOS? How would you update EOS to EOS? EOS is updated to EOS. So this is the answer then. Okay, that's dumb. I need to update this flashcard. But ultimately, how could you do that in Pandas? How would you be able to update the index column, which is athletes, and update this EOS, this name, from a Y to a J? And if I'm recalling correctly, what I would do is import pandas PD. From there, we do dataframe.read CSV, whatever the CSV file would be, and then from there, we'd go ahead and make sure that the index is actually at athletes. But once the index is for sure athlete, what I would do is dataframe.rename, and then in brackets, I'd have like a dictionary symbol, the curly cues. And then in the curly cues, what I would have on the left-hand side, it would be the first name, which would be just EOS Alfred, and then it'd be a colon, and then EOS Alfred again, but with a J. And both of those, the old name and the new name, would be in the string. And then I'd go ahead and do access equals index, and then I'd do inplace equals true. So if we were to show this, what it would look like is we're importing the summer data set, and then we're setting the index column to athlete, so that way it's already established. And notice how EOS is with a J instead of a Y. So summer.head, EOS Alfred, and if we scroll down, if we were going to rename this, it was what I said earlier, so it'd be summer.rename, and then we'd have, within the entire brackets at least, we'd have a dictionary, and pretty much a string of the old name, which is EOS with a J, and then we change that to EOS with a Y. And then access equals index and in place equals true. So I was able to remember that. And because I feel confident in it, I'm just going to go ahead and click good so that way I can study it again. For those of you that are really confident in being able to update index values, go ahead and just click easy, and then you'll be able to move on. And I'm actually tempted to click easy right now, but for the sake of this, let's just click good for today, and then I'll click easy as time goes on. Okay, so next one. What does the following output if we use the summer data set? So we have the summer data set, and we have summer.rename gender to sex, comma, city to host city, and then access equals column, and inplace equals true. So where's gender? Gender, and then city, city. So what would happen in, because we're working with the columns, is this column gender would transition to sex, so that'd be the new column name, and then likewise city would then become host city. And because it's in place, rather than saving it to a variable, so it'd be like, rather than saying summer equals summer.rename, because we're using in place, that value in place will make the change occur on that one line of code, right? So if we were to show the answer, it renames the columns, gender becomes sex, city becomes host city. So host city from city, and then sex, which used to be gender. So it would be old name to new name, old name, new name. And I feel really confident in remembering this, but I'm going to just click good. Next up, so what does the following output if we use the summer data set? So let's say you want to reset your index with the year column. How can you do this? So what are we doing? So we're essentially reset your index with year. And since our index is athlete, what we would do is we do summer, essentially calling the data frame, dot set underscore index. I'm tempted to bring in like a notepad, like another one. Can I just click on this without opening any of my old ones? What do we want to do? So what I decided to do, hopefully I clipped this portion out, but what I did is I pretty much just brought in like a new notepad so then we could see what I'm typing in, and let's make this larger so it's easier to see. 96. So what I'm thinking is it'd be data frame, which would pretty much be summer. So summer dot, maybe this is too big. Let's make it 64. That's a little better. So summer dot set index, and then from there it would be, what would it be? Set index. I'm thinking again it's the dictionary, and from there it'd be, oh well, thank you notepad. So we would do athlete and year, and then we could just do axis equals index, and then in place equals true. So that's what my answer is to this, or like that's what I'm, like the flashcard, like, yeah, that's what I'm gonna say my answer is. Anything else? Summer.index, curly cues, axis, index, in place true. Let's just go ahead and run it and see. So before I do though, the reason I'm saying year, let's just run it. Look what the answer is. So drop equals true. So that's where I screwed up. Okay. So the screw up then is with the summer as our data frame, dot set index, which is correct, which was my initial guess, year. So we're selecting the year, and then we're going to drop, which equals true, and in place equals true. Now I have done, I've done like a quick search online to make sure that this is a valid response, like what drop really does. So what drop does is it takes the year column and it drops it. And then what happens is the year column, I guess, gets saved in memory, but it essentially becomes the index. And then athlete, luckily because we didn't drop it, like it knows that this gets bumped over to this higher level of where all the other column names are located. So that's what drop does. It just drops the column that we want to be the new index, and then we do it in place. So it's true. I feel good with it because I did study this yesterday, and I remember having to look up this, what drop does. I just hope that next time I'll go ahead and remember that instead it is year. So just remember year and no axis, but we will be dropping, which is equal to true. Drop equals true. And the reason I'm typing this out is because just the more you practice with the code, the better it becomes. I learned that quite well with SQL. That was not fun. But anyways, we'll go ahead and select good. So the next question. It renames the column, gender becomes sex, and then city becomes host city. So this is already giving us the answer. What would the question then be? How would we be able to update our summer data frame and update the host city to be city? And how would you update sex to be gender? Well, since we already went over this, it would be summer dot rename, and then curly brackets, and it would be, well, double V. Nope, still does it. Host city, and then will then become city, and then from there, what we could do is we could do, I don't like how it does that. We could do sex, then becomes gender, and then from there we'd pretty much be done with these curly brackets. I'm thinking, what would happen? Nope. Yeah, I don't want to make this like larger, and I do wish I had another computer screen, but oh well. And then we'll do access equals columns with an S, yeah, and then inplace equals true. Now let's go ahead and see if that's right. So the answer then becomes summer.rename, which is what we did, summer.rename, gender, which is city. So I did in the opposite direction. So it goes old name, new name, and before this update, it was gender, and then sex. So gender then became sex, and then city, which is located here, became host city. And I was just working in backwards. So host city, we transitioned it back into city. So old name, new name, old name, new name. Access equals columns with an S, yep. And then in place equals true because we want to be done on that line of code rather than setting it to a variable. Perfect. I feel confident in it. Yeah, let's do easy. Okay. So with the below output, how can we locate the two values that show as strings? So this is a different data set. So rather than the summer data set, which we've been working on, it's invoices, and it has the meal price column. And then what we're doing is, with the below output, how can we locate the two values that shows a string? So these two values. So in essence, what this does is it takes the invoices data frame, and we're selecting the meals price column, and what we're doing is we're saying apply lambda x type of x. So what we're doing is we're locating the different types or the different data types that are located in this specific column, and we're going to go ahead and do the value counts, which will return an integer value count of 49,000, and then a class or a string / object count of 2. Generally speaking, if I'm not mistaken, I believe if there are nan or null values, that there will be also a 2 that they'll count as a string or an object, if I'm not mistaken. But you'll want to definitely run the code and see how many null values there are. And so if you were going to do that, in order to see the null values, just do dataframe.is_na and then .sum, and that'll give you the null values. But because our goal is to identify what the actual value is of both of these, what we would do is, I might want to make this smaller. So how about 48 now? So invoices. I hope I'm doing this right. Invoices, meal price. I'm going to go ahead and just copy this because I don't want to keep having to paste it. Equals invoice meal price. So we're doing it twice in essence. Let's make this a little bit bigger so then we can see it. So imagine that this is one line of code, if you will. It's a bad line of code. But anyways, so we're going to take the invoice, data frame, meal price, invoice, meal price again. Not sure why. All I know is that that's the answer, and when we run the code in Colab, it'll be updated as well. So if I'm not mistaken, it'd be lambda x is instance x stir. Yes, no, what are you doing? X comma stir, and I feel like I'm missing another part. I don't know. I think that that's it. But imagine this on like one line of code. So invoice meals price equals this. Yeah, okay. I think that this is right. So I'm gonna make it smaller. Let's show the answer. So did I screw up? I did. Where? That's why. Okay. So rather than saving it to like a variable, to the same variable, all they're doing is they're taking the data frame of this column, meal price, and then within that we're going to locate, that's where I screwed up. So meal price, and then we would have another bracket, and then bracket again. So then we close that out. So this one is located on the same level as this one. And let's just press enter one more time just for like visual purposes. So data frame meal price, invoices meal price dot apply lambda x is instance x of string. So we're locating the string, all string values that are in the data frame with a Python built-in function, which is instance. So in essence, all it's looking for is any string value that is located in X, like as a any string value located in the meal price. And all X is pretty much every value within the column meal price. So that's what the output is here. And then hopefully I'll remember that when we start working on when I start working in Colab. Okay, I feel, let's try to set that to hard. Okay, and then the next one we have summer.setIndex year drop equals true and place equals true. So again, this is the answer, and all we did is we switched athlete, which was the original index, to here. Now if there was no index, what would happen is we would still drop the year column, which would have been between athlete and city, and then we would have done it in place, and then the index would just be like 0, 1, 2, 3, 4, 5. It would just be counting the length of rows. So I feel really confident in the, maybe not. Yeah, and actually in this answer one I feel confident. I don't want to see it again, so I'm gonna just click yes. Yeah. Now, how can you use pd.toDateTime to guess the date and time? Well, I mean, we would just use just that. So all that is really happening is when we use pd.toDateTime, is we're pretty much just printing whatever the date and time are. And if I'm not mistaken, I think there's a number of ways that the date and time can be written. Like it could be like August, like 8th of like 2017 or whatever. Or it could be, we'll just go ahead and copy this one again. It could be like 08 17, if I'm not mistaken. So let's go ahead and click the answer. But in essence, all you do is you just use print. If you're not like in a Colab or notebook or something. So print pd.toDateTime, and I had it as 08, so I was wrong. So it looks like what's happening is these are the different times that it could be written in. And honestly, if I was you, I would just experiment with whatever string it might be. So for example, I would test August 8th, 2017 to see if the output would match the other outputs of like 2019, 01, 08. So it would be August 1st of 2019, right? Yeah, because August 1st, 2019. So that's just kind of a cool little trick. I rarely use this in the real world. Well, yeah, maybe like when I'm joining data together. Actually, yeah, when I am joining data together, I will. But usually it'll be like the last day of the month or something like that. And you can always Google how to locate the last day of the month based on like when a customer purchases a product. So let's just set that to good. And I'll do a handful more of these and then we'll just dive into the other one. So what does the following output if we use a summer data set? How can you determine if your index is unique? My mind went blank. I don't know. If your index is unique, maybe I need to reword the question then for myself and for others. How can you determine if your index is unique? Like, my mind is just going to like length of athlete, or like maybe, I don't know, athlete unique, something like that. But that would just give us the count of unique values in athlete. And then I'm even thinking that that's wrong because this is the index. And let's see what the answer is. Streamer.index is unique. Wow. Okay. So that one was tough. So it would be dataframe.index.is unique. I almost feel like, let's go ahead and check it out. Brave. Whoops. Dataframe.index is unique. So let's see what this really says and like how to really write it. Thanks Pandas. So index.is unique. Index.is unique. Okay, so there's no like brackets at the end. That's what I was really looking for. Nope. Yep. So dataframe.is index unique. Let's go ahead and just test this one more time in like a minute. Okay. So this is another answer to how would you rename all of the columns in your data frame? Or like how would you rename the first column in your data frame? And the question to this answer, this is the answer, the question is Titanic.columns, and then here we would have a slice. So like what does this return? So what does Titanic.columns 0 equals alive? What's the output of running this code? And the answer is it's an index, or it's a type error. The index does not support mutable operations. So in order to rename alive, or rename survive, which is the original name of this before it gets updated, is you could do this essentially, just type out all of the columns. So it'd be Titanic.columns equals a list of strings, and whatever place you happen to place the updated name in will like have it updated. Will have your column updated. And if you remember earlier, you could also use dataframe.rename to go ahead and update your column, like a specific column. And then here's another example. So this is just a different data set. Don't worry about whatever the data set is. But what I mentioned earlier is dataframe.rename columns equals old column name, new column name, axis equals true, and then what you might also want to do is comma in place equals true. In place equals true. True. Or you could do columns.string.upper, so you could capitalize all of them if you would like, and then or even slice them with a lambda function. Column equals lambda x slice 1. So then instead of it being name, we just have aim. And then what else? Or set axis. So then that would go ahead and update the columns, each column name. But just beware that when you do update a column name, that the values don't change, just the name does. So Bill used to be right here, it's now here. Name was there, and then type was there. So type restaurant, and yeah. Okay. I kind of want to revisit this, mostly because I think that set axis would just be easy to remember. But I also think that remembering this one would probably be the best bet, and also adding in place equals true. So let's go ahead and do that now. In place, comma, in place equals true. Perfect. Okay. Show answer again. Okay, good. Yeah, and that was what I mentioned earlier. This would return a error. So let's go ahead and see that in 2 days. What does the following output if we use the summer data set? I feel like I should get rid of this. How can you determine if your index is unique? We use dot is data frame dot, why am I blanking? Set, why can't I remember this? I'm picturing in unique there. Oh, this is lame. Index dot is unique. So data frame dot index dot is unique. Data frame dot index dot is unique. Okay. What else do we have? So this is the answer to the question that we asked earlier. How can you identify the different data types in a specific column? So if you can, using the invoices data frame and the meal price column, how can you identify the different types of data in the meal price data frame? And how can you have the total count of each data type? So rather than having this as our answer, we're going to try to work backwards and identify where the string values are in a data or in a column, and where the integers are in a column. So if I'm not mistaken, it'd be invoices, meal price, and then from there it would be dot apply, and then it would be lambda x type of x, and then we do value counts underscore counts, and then that should be it. So this would be what it would look like if it was on one line. So data frame meal price dot apply lambda x type of x. So we're seeing what the different data type is for value counts. And remember, when you run this code, to also check for null or NaN values. Let's go ahead and show the answer. So like I said earlier, invoices meal price that apply lambda x. Cool. So I was able to get that right, and we were able to identify this. And now if you want, go ahead and try to work backwards. Like put a little sticky note on your computer screen and just block out this and try to recall it. Yeah. Thinking about the word recall just reminded me of when I started studying PyTorch. So let's go ahead and click. That one's good, and I don't really want to see the answer again. And now we have the answer pop up again. Okay. So how do we identify if there's a unique value in the index? Summer.index.isUnique. And now I actually am curious. I think I'm going to go ahead and hop into the Colab, and what we're going to do is we're going to check if there are different unique values in a column. So let's bring that up. So So what I'm working with here is I'm working with the did-it-rain dataset, which can be found on Kaggle. All you've got to do is locate it, upload it to your drive for Google, for your Google account, whatever. And then, pretty much just unzip it and do all the rest. But once you're able to access it, go ahead and bring in the data. So import pandas as PD, data frame equals pd.read CSV, and then data frame.head. And now what I wanted to do is go ahead and recall all the things that we just worked on, or at least try to recall them. And so let's go ahead and see what the data frame.columns are first. So we can go ahead and pick one of them. Oh, I didn't run it. df. Right? Good, good, perfect. Okay, so let's go ahead and see this. Dataframe.date. So let's go ahead and see if the date column is unique. False. Okay, so it does work. So rather than, so is unique will work for a column as well as an index. Let's go ahead and see what the index is. And don't forget, so the index would be, let's go ahead and see what the dataframe.head, let's go like 20 rows. So the index, in essence, would be 0. Each value should have its own unique value, is what I'm getting at. Let's go ahead and zoom in just a bit so we can have more people view it. Okay, just reading a message. So dataframe.index.isUnique. Wait, I didn't run that one. So that one's true. Yeah. And then how would we go ahead and reset the, dang it. We'll go ahead and reset the index. So if I were index column, if we were to just review this, dataframe.head, let's go ahead and have the date as the index. How do we do that? What we do is we would do dataframe dot, what was it? I'm already blanking. What would it be? Set index. Boom. Set index. And then from there it'd be a string, which would be date drop equals true, and in place equals true. If we run that, we'll go ahead and view it. Boom. So that's how we update the data frame, or that's how we update the index. So we use dot set index, drop equals true, and place equals true, and then data frame. Now I'm curious, what would happen if we set rainfall to the date and if we didn't drop it? So like what I mean is, what if we did set index to rain, and then from there we did not do drop. So drop is already true, so let's set drop to false, and in place equals true. Let's see what happens. So none of the rain, what is it called then? Oh, it's called rainfall. Rainfall. So we now have we've lost our date column. So that's no fun. Let's go ahead and re-bring in the data so I can just kind of see it, and let's just set you to pass. So now I've brought in the data again, and dataframe.setIndex date drop equals true and place equals true. That's fine. Actually, I didn't want to do that. How would we bring the index back? So I didn't have that as a flashcard, but I'm curious how to make index column pandas. How to convert index to column in pandas data frame. df.resetIndex. Well, that was easy. df.reset index in place equals true. Equals true. Set it. Don't know what I did. Let's just look at the head. Okay, perfect. So if we do have an index that we set, which date was that index, then we can reset it with reset with reset index. Wow. Okay. In place equals true. Is there anything else? No. So now for fun, let's go ahead and see the nan or null values, and then let's go ahead and look at the different data types in a specific column. So df.isNA.sum. So what do we have? We have date, location, min temperature. Now, what would be the data type for min temp? So df.mintemp.dtype, if I'm not mistaken. So it's a float. Let's go ahead and see if a null or nan, aka nan, I gotta just like pick null or nan, just stay with one. If a blank value is a string or a float. So how do we be able to identify the different data types in a specific column? Well, what we do is we do df.mintemp.apply, right? Yep. Lambda x type of x dot value counts, and let's go ahead and see what that is. So float. So float is, so we only have float then, but this is in essence how you identify the different data types. Let's go ahead and test one thing then. I'm blanking. I wanted to test something, but I'm blanking. .mintemp. Oh, that's right. So I wanted to see what the total row count is for this data frame. So all of the values are actually just a float. Let's just go ahead and test one more. Or like, let's do df.info. Info. Let's go ahead and check what the object is. So wind direction at 9 a.m. So df.winddirection 9 a.m. dot apply. So we're attempting to identify what the different count of data types are in the column. So how many string values, how many integers, and how many floats are in this wind direction at 9 a.m. column. Apply lambda x, and then we're going to go ahead and do type of x, and then from there it'll be value counts, right? Boom. Okay. And then, so let's go ahead and see df.windType again. Wind direction .dtypes. So it's an O. So O means object, which is a string value, and that's why these are string values. Is that really? How many null values do we have for wind direction? At 9 a.m. So let's go ahead and see the null values, and then we'll have a better understanding of it. Wind direction at 9 a.m. .sum .is na .sum. Okay, so there's 1056. So then what this is telling me then is that nan values are numeric in nature. Okay. So that kind of ruins what I wanted to show next. But for this sake, let's go ahead and just look up what the float values are for df.wind direction. And let's go ahead and just save it as a new data frame. So we'll call this df.wind, df.wind. We'll do camel case. equals data frame. So in essence, what I'm doing here is I want to identify what values are actually floats, considered floats in the wind direction at 9 a.m. column. So let's go ahead and do winder, winder at 9 a.m. Dot apply lambda x, and then if you remember, do you remember the Python built-in function that we mentioned in the flashcards? If you want, feel free to pause and like rewind. I'll get better at that in like future videos, describing like what I'm going through and what's going through my mind, but I'm just kind of going, yeah, I'm just kind of running. So if you don't remember, that's okay. So it'd be is instance, and then from there it'd be x, which would be the value, and then from there, or x is the object, whatever, but from there it is float. Yeah, I don't know why I feel like there's supposed to be more. So df.win direction at 9 a.m. apply lambda of x is instance x float. Yeah, and let's go ahead and run it. So df wind, and I'm thinking of adding like value counts there. So these all show as false. They're not even showing as nan. But what am I doing? Oh, okay. So let's go ahead and see where it's equal to true. df.wind dot locate, if I'm not mistaken. df wind equals true. Right? Boom. Cool. I'm iffy on those locations. So what just happened is, in essence, let's just zoom out a bit, is we're looking at the data frame wind, which is our variable, and we're locating where it's equal to float. Oh no, so I screwed that up. But regardless, what we're doing is we're identifying where a float is in the data frame, and all of these are shown as false. But lines 15, sorry, yeah, row 15, 26, 65, 86, and so on, all have true. Although, no, that's right. And let's just go ahead and do like value counts. So then we could just see like the total count. So this count is 1056.6, and our null values likewise are 1056.6. Okay. Okay. I was just trying to recall how I was able to identify the name. That's it. I just figured out. Okay. So what we're going to do here is let's go ahead and add df.wind direction at 9 a.m. And we're going to go ahead and add this as our like what we're locating, right? So we want to locate the actual value. So the reason I was hesitant and was a little awkward a little earlier was because I knew, or I felt that there was another piece of the puzzle that we needed to identify what the actual value is. I didn't want to really see false or true. I wanted to see the value. So let's go ahead and run it. And we see that they're all nan. So that's how it's done. Okay, I feel better. And then what else can we study? So I'm kind of coming up on like my 1 hour or 40-minute mark or so. But what I think I'll do is I will go ahead and end this video here. Go ahead and I'll add this to a GitHub, so then you guys can go ahead and practice with it. And just remember, when practicing flashcards or really anything, that it's really useful to have an end goal in mind. Looking at data is fine, but honestly, building something will make you so much better at your programming skills. So try to take your own financial statement or something and then work with that and identify your own habits. Go ahead and work with Pandas, work with matplotlib, Seaborn. Use something that will be useful for you when you're looking at your own data, or if you're attempting to build, I don't know, whatever, just build something. So with that said, I'll go ahead and end this video here. Yeah, I'm going to go ahead and also add a Snugg, Snugg link, which all Snugg really is it's pretty much just one-on-one conversations. So you can go ahead and speak with me, and I'm going to focus like tutoring on Snugg. And in time, after I create like 1,000 of these videos, like 3 a day, I'm sure my time will get booked up. So just know that prices will increase in time. But for now, I'll focus on helping anyone that's new with Pandas or SQL. I'm quite good at SQL. Just don't ask me how to use variables. But otherwise, left joins, inner joins, all those things, and everything in between, hierarchical data, I'll be happy to help. So yeah, so I'll end this video here. Thanks for watching, and I'll see you in the next one.